Hello. In this video, we're talking about for loops. So we've already introduced the concept of a loop before when we talked about while loops. And those allowed you to take a block of code and repeat it many times. Now, for loops do something similar. You can also repeat a block of code many times. However, they turn out to be a lot more common than while loops. So why is this? Why are for loops used more than while loops? Well, you'll remember that one of the things about a while loop was that there was no limit on how many iterations it would take. And that was useful when, for example, we were interacting with a human user and we didn't know beforehand how many tries they were going to need. However, it also opens the door to the problem or the potential problem of an infinite loop. So it's actually a lot more common that you do know how many iterations you're going to need to do something, or at least you have an upper limit on the number of iterations that you need. And in that case, you'll want to use a for loop. Okay, let's see how for loops work. As I said, a for loop is going to repeat a block of code many times. But how many times? Well, it's going to execute the block of code once for each element of a collection. So a for loop is essentially iterating through a collection that you give it. And it can be any type of collection. It can be a list, a tuple, a string, a set, or a dictionary. So any of the 5 types that we've seen. So let's look at an example. Say you have this collection, it's a list, and it has 3 items, and you want to print the 3 items. So the way we do that is first the keyword for, and then a variable name that is going to be assigned to each of these items in turn. Then the keyword in, and then the collection. So you say for a in, and then the collection or a variable name that refers to the collection. And then comes the block of code that is indented with respect to for, and of course, don't forget the colon. So what's going to happen here is that first, A will take on the value of the first item in the list. And then it's going to execute the code, which is print A, and so it's going to print the first item. Then, once it's finished with this block of code, A will take on the value of the second item, and then it will execute the block of code again, it will print the second item, and then finally the third item, it will print the third item, and then the for loop is done. So the more formal syntax for this is that you say for A in capital A, which is a collection, and then you have a colon, enter, you have an indent, and then you have a block of code that can contain any number of lines. So let's look at an example of this in code. Here's the first example. Say we have a list like this one with the radiuses of 4 circles, and we want to compute the areas corresponding to those radiuses. So essentially we want to apply the formula pi r squared to each of the elements in this list. Let's do that with a for loop. So we start by typing for, and then we give a variable name that's going to be applied to each of the elements of the collection, and then we give the name, the keyword in, and then the name of the collection, in this case a list called radiuses. Then we say colon, and now we can add our block of code. Now that code is going to begin with the computation of the area, which is pi r squared. So we say pi, but then we notice that we need to get pi from the math library. So we need to import math. Let's do that. Import math. And so now I have pi. Then I can multiply it by the radius squared. And this gives me the area corresponding to this radius. Well, if we want to preserve these areas, we need to save them in a list. So let's create that list, and we're going to call it areas, and we're going to initialize it to an empty list. There are 2 ways of doing that. You can either use open close brackets, that will create an empty list, or you can use the list constructor and pass in no arguments, and that will also create an empty list Which you choose is just a matter of taste. So now that we have an empty list, we want to add this area to that list. So we're going to grow the list within the for loop. And we do that with the method append, and we pass in the area, and that adds the area to the list. So now we're done. We run our code, and we have the areas for the 4 circles. There you have it. Well, the last thing I want you to notice is that this would have worked exactly the same if this had been a tuple, because nowhere here have we tried to modify the list radiuses. So it can be a tuple, no problem, and this works just the same. Okay, on to the next example. What if instead of iterating through a tuple or a list, we iterated through a set? Well, you'll recall that tuples and lists are examples of ordered collections, while a set is not ordered. So that means that when you iterate through a set, there is no guarantee that the items will come out in the same order in which you put them in, or the order in which you define the set. Let's look at an example. So here we have a set of country names, and I'm just going to iterate through them with a for loop and print each one. So we see that the first one that comes out is Indonesia, and that is the fourth in the definition of the set. So already we can see that the order is not the same. And furthermore, if I start the kernel again and rerun this code, the order may turn out to be completely different. So yes, here we see China comes out first. So the order is not guaranteed to be the same on 2 different executions, and it's also not guaranteed to be the same on your computer as on someone else's computer. So that's just something to be aware of. Next, I want to show you how to iterate through a dictionary. We'll use as our example the 5 most populous countries with their names and respective populations, which we had stored as a dictionary. The thing to remember is that dictionaries, like sets, are unordered, so the items can come out in any order. There are essentially 3 ways of iterating through a dictionary. The first, and most obvious, is simply to use the same syntax as before. That is, we use the for keyword, then we give a variable name, then the in keyword, then the name of the dictionary, then a colon, and then the body of our iteration. Now, what do you think that this variable x will have? Will it have the keys? Will it have the values? Or somehow will it have both the key value pair? Well, let's see. It has the keys, the names of the countries. So when you use this sort of syntax, you get in X the keys of the dictionary. Okay, once you have the keys, you can very easily get the values by calling the dictionary, querying the dictionary with that key, and that would give you the corresponding value. So now I have the value and I can print it out as well. Okay, that's method number 1. But sometimes you don't actually want the keys. You're only interested in the values. Say, for example, if you wanted to find the total population of the 5 most populous countries, you wouldn't be interested in their names. So in that case, you can call the values method on the dictionary, and that will return a collection with only the values that you can iterate through. So in this case, it gives me the populations. And say if I wanted to find the total population, I could do that by defining a summation variable, initialize it to 0, and then I can say s is equal to s plus x in each iteration. And then when we're done, I can print out S, the total population of the 5 most populous countries. Okay, well, sometimes you need both. So a convenient way of doing that is to call the items method on the dictionary, and that will return tuples consisting of key and value. And that tuple you can unpack in the for line itself into a key value and a key value and a value. In this case, it's going to be the name of the country and the population of the country. So we can get them both at once using the items method. Another example. Let's say that you want to create a program that translates words in English into words in Spanish. And you're given this data. It consists of two lists, one called E that has the words in English, let's say the names of the numbers from 0 to 3. The other list has the corresponding words in Spanish. So first question is, what sort of data structure should we use to hold this information in your program? So the program is inherently a map from a set of words in English to a set of words in Spanish. So this suggests that what we need is a dictionary. And that dictionary, when we query it, let's call it E2S, when we query it with a word in English, it should return the translation in Spanish. Okay, sounds like a plan. Let's build this. So our first step is to create an empty dictionary. And then after that, we're going to use a for loop to fill our dictionary with the key value pairs. So how do we create an empty dictionary? Well, if it were a list, we would have used open close square brackets, or we could have used the list constructor. Now, since it's a dictionary, can it be that we can use open close curly brackets and to create a dictionary and not a set? Well, let's see. The type of that is indeed a dictionary. So open close curly brackets creates the dictionary. But we could also have used the constructor, and that gives us a dictionary, or we could have used the set constructor if we wanted a set. Now, I tend to prefer the constructors for precisely this reason, because it removes the ambiguity of whether we're creating a dictionary or a set. So let's use the constructor dictionary. Now we have an empty dictionary. The next thing we want to do is clearly to iterate through the words in English and thus build our dictionary. So the iteration is going to be for E, lowercase e is each word in our list of words, E. For now, let's just print out E. And yes, we have all of our words in English. What we want to do is in our dictionary to assign to that word, English word, assign it the corresponding word in Spanish. But here we run into a problem. How do we get this lowercase s, which is the word in Spanish that corresponds to the lowercase word e in English? Well, I'm going to show you three ways of doing this. One with a range, two with the keyword enumerate, and the function enumerate, and three with a zip. All three of these are going to show up in the for line, and they really just round out our understanding of for loops. So let's see how they work. This table provides the description and syntax for the three built-in methods that I just mentioned: range, enumerate, and zip. So let's start with range. Range will feel familiar to people who have done for loops in other languages such as Java or MATLAB or C, where instead of iterating through a collection, you iterate through a range of integers. And that's exactly what range generates. It generates a sequence of integers. Now, the syntax for range is very similar to that of slices. So you give a start value, a stop value, and a step value. Of these three, only the stop value is required, and it's also non-inclusive. So let's see a quick example of that. So how do we use range in a for loop? So we say for I in range of, for example, 4, that is going to generate the integers from 0 to 3. So non-inclusive, as I said, of the stop value. Let's say we wanted to start not from 0, but start from, say, 2. Then we'd provide 2 as the start value, and we get integers from 2 to 3. Let's go a little bit further and now add a step value. This is going to generate the integers from 2 through 19 in increments of 4. So 2, 6, 10, 14, and 18. Okay, how can this help us to solve our problem? Well, instead of iterating through E, the elements of E, we're going to iterate through the indexes of E. So we say for I in range. We would like to put here 4 because 4 is the length of E, but let's just say length of E. Now we have indexes that we can use to get values of E. So I say E is, lowercase e is the ith value in E. That gives me the English words. And the lowercase s is going to be the ith value of the Spanish list. There you go. So now we can simply say E2s of the English word is equal to the Spanish word. And we have created our dictionary. Okay, let's look at enumerate. Enumerate is nice because it returns both the index and the value of a collection. So when you call enumerate and pass in a collection, it's going to generate indexes I and the corresponding values A. So let's see that in our example. Let's add a cell below, and we'll do the same thing as before, except we'll use enumerate instead of range. So when we use enumerate, we're going to get, in addition to the index, we're going to get the value when we call enumerate on the list E. Okay, so enumerate returns the index as well as the value from the list. And so since we have the value from the list, we no longer have to extract it explicitly. So we only use the index I to get the word in Spanish. And that works perfectly well to make our dictionary. Okay, next is zip. You can use zip to quote-unquote zip together multiple sequences that are of the same length. So we have, in our example, we have two lists of the same length. And when we pass them into zip, so pass E and S into zip, it's going to generate tuples starting with the first two elements, 0 and 0, and then going on to the second and the third and so forth. So zip can be used to iterate simultaneously through multiple collections, or rather through multiple sequences. They have to be ordered. And they can be multiple, not only two. You can use zip to iterate through 3, 4, 5, any number of sequences simultaneously. So let's see how that applies to our problem. Okay, now with zip, as I said before, you're going to pass into zip the two lists, and it's going to return the pair of words that go with each other. Then you can directly use those words to populate your dictionary, and we never needed the index I. So I would say that this is the most elegant of the three ways of solving this problem because it doesn't involve the index I, which we never really needed. And we get our desired dictionary with just 2 lines of code. Well, that's it for for loops. I've shown you 3 ways of doing the same problem with range, enumerate, and zip, and there are others. So I'd be remiss if I didn't mention that you can do this directly with the constructor of the dictionary, which can take some arguments, and if you pass in the zip, it will produce your dictionary straight away with just 1 line of code. So that's a little bit advanced, not necessary for you to do this, but it just demonstrates that there are always multiple ways of doing things in Python, and which one you choose is really a matter of taste. As you practice, you will likely converge on your preferred way of doing things that even if it's not the most advanced, there are advantages to being consistent and explicit about things so that your code becomes easier to read. Okay, that's it for this video. I'll see you next time.